Hello everyone, I hope you're having a good Codegarden so far, and thanks for coming to my talk on the topic of Umbraco Deploy. Firstly, let me quickly introduce myself. My name is Andy Butland, and I've been part of the Umbraco community for many years. Until recently, I worked at digital agency and Gold Partners Zone, and have been recognised as an Umbraco MVP for the past 5 years. This was primarily through open source contributions that most recently have been focused on the development of Umbraco version 9, through being part of the community team working to that aim. As of March though, I'm now an Umbraco employee, joining as a developer with a focus to work on HQ's commercial packages, Umbraco Forms and Umbraco Deploy. When it comes to these products, my aim since joining has been to focus on 3 phases of work. Firstly, we've made progress on stabilisation of the products, providing the attention to them that historically has been difficult to find without dedicated people working on them, in resolving a lot of small issues, usability concerns, and adding minor but necessary features. Over the past few weeks, most of our attention has been on the migration of these packages to .NET 5, in order that along with the release of v9 of the CMS, we also have companion releases for the HQ packages. And moving forward, as v9 is released and bedded in, we plan to move on to more significant feature development, implementing some long-standing requests and improving the integration experience. For my talk today, you're actually going to get 2 for the price of 1, both related to Umbraco Deploy, but with a focus on 2 different topics. Firstly, I'm going to talk about Umbraco Deploy on premises and how you can use this in your own environment outside of Umbraco Cloud. In particular, I'm going to look at how you can set up your continuous integration or delivery pipeline to make best use of the tool. And secondly, I'd like to discuss some of the integration points for Umbraco Deploy when working with your own data, i.e. with things other than Umbraco content and schema. This isn't something that everyone needs to do, of course, but for certain packages and solutions, there can be value in storing information in ways other than as Umbraco content, but still allowing editors to manage it via the Backoffice. Some of these features are available now, and some are at a peak of what we've been working on and will be coming soon. Let's start though by making sure we're all on the same page with regards to what Umbraco Deploy is. It's a tool built and maintained by HQ that is heavily used by Umbraco Cloud for the deployment of Umbraco schema and content between environments. It's also, released a couple of months ago, a commercial package called Umbraco Deploy on premises that customers can purchase and use in their own environments outside of Umbraco Cloud. As you'd expect, there's a lot of overlap between these 2 versions, with the vast majority of the code being shared between the 2. And as such, customers of the on-premises version can benefit from the work that goes on to improve and optimize the experience for cloud, not to mention the many years and exposure to different Umbraco installations the product has had through its use on cloud. Its broad function is to support the transfer of Umbraco schema, i.e. document types, data types, and Umbraco content, such as documents, media, and optionally forms, between environments. It does this in 2 ways, and firstly we'll consider Umbraco schema. These are items that normally developers work on, found in the settings section of the Backoffice. With Deploy installed, events are hooked up such that any change to the schema is written to a file on disk. And although you don't need to edit these files, you can find them in the data revision folder for your installation, and you'll see they all have a UDA extension and they contain a JSON representation of the serialized schema item. These schema files then need to be copied to the target environment, from where they can be restored to the target database and thus update the Umbraco installation there and make them available for use by editors. Let's quickly look at this using a manual process for copying the files. The website I'm working on is a local development environment with the Umbraco starter kit deployed, where I'm going to make a small change, adding a new property to a document type. With that added and saved, if we take a look at the files on disk, we can see a new file with a UDA extension has been created in the data revisions folder. If we open it up and take a look, we can see it's a serialized representation of the document type, including the newly added property. We should now commit this file to our source code repository, along with any other code changes that have been made. Deployments these days are of course usually more sophisticated than simple file copy operations that I'm going to demonstrate here. As we'll discuss shortly, we're expecting a CI/CD pipeline to take control here and ensure that these UDA files containing the schema information are deployed along with the website's templates, client-side assets, and compiled code. For now though, I'll copy the file to the file system of the target environment and open the Backoffice there. Switching to Settings and the Deploy dashboard, I can trigger a read of the schema from disk. And when that completes, we can see the new property is now present in the target environment. As well as schema, Umbraco Deploy can also be used to deploy content, media and forms, i.e. features that editors will be updating in the Backoffice. And whereas schema is intended for deployment up the environments, i.e. from dev to test to live, content can be transferred in both directions. Developers and testers may have a need for replicating production content in lower environments, which they can do by restoring it. And if you prefer a setup where editors create content not in production but in a staging environment, that can be supported too via the queue for transfer and the transfer now features. The difference between the schema and content methods are in the medium used for the transfer. Rather than files on disk, the JSON serialization of the content items is passed via HTTP requests from the source to the target environment. In this scenario, I've created a new page in a staging environment and want to promote it to live. I can do this either via the button available on the content item itself, or by queuing the update for transfer and then triggering it in a batch along with others. The content will then be transferred to the destination site and published. We can also carry out the reverse operation. For example, as a developer, we may want to retrieve content from the production site into our local environment for working on a bug fix. Umbraco Deploy is a tool that will help you in your schema migrations through environments. But in order to work in an automated fashion, there are a few requirements of your source control and your CI/CD pipeline. An important first point is that these requirements don't dictate the use of a particular build and deployment solution. Whether it's Azure DevOps, GitHub Actions, TeamCity, Octopus Deploy or something else, we'd expect you to continue to be able to use the tool and tools of your choice. Above and beyond the normal steps of a build pipeline for a web application, tasks like NuGet restore, solution build, running of tests, etc., Umbraco Deploy requires two additional steps. Firstly, we need to ensure that the schema files written to disk are included in source control, and from there are available in the build artifact that is deployed to the target environment. And secondly, once the build is complete, we need to trigger the extraction of the updated schema in the target environment, thus avoiding us having to do this via the Backoffice dashboard. Just a note for reference, all that I'll be discussing today has been documented as part of the Umbraco Deploy documentation that you can access via the URL shown here. Before looking at how we implement these steps, let's first review some settings that need to be applied to your Umbraco project when using Deploy. When you install Deploy, you'll find two settings files in the config folder that need to be populated. The first should contain references to your upstream environments. Here I've got just one, the live environment, and this setting would be appropriate for my local development machine. Each environment has a name, a unique ID, and a URL. The second file has just one option, only relevant if you're also using Umbraco Forms. You have the option to deploy forms as content, i.e. via the Backoffice by editors, or as schema by developers, so you can pick the option that best suits your workflow. In web config, we need to add an API key, common across all environments and used, as you'll see shortly, for authenticating the deployment trigger. And finally, a publish profile containing the displayed details should be added to the solution, one that will be used in the CI/CD pipeline to publish the built web application to the file system, from where it can be bundled for deployment. Adding the data files to source control is straightforward enough. They will appear as changed files within the local Git repository and can be added, committed and pushed in the normal way. Your git ignore file should include the line shown on the slide. This will exclude the temporary files generated by deploy that always have a deploy prefix, but importantly still include all the generated schema files. .NET developers, I'm sure, will be familiar with the situation of deploying a web application and finding certain files haven't made it to the target environment due to them not being referenced in the project file. These schema files won't be and shouldn't be, but we'll need to make sure that the CI/CD pipeline has a step that handles their inclusion in the deployable build artifact. Then we need to look at the process for triggering the extraction of the schema files in the target environment. There's actually a few ways to do this, and all are possible ways to use, but as you'll see, we have a recommended approach that we ship Umbraco Deploy on premises with. When I triggered the extraction in the Backoffice using the dashboard, behind the scenes what happened was a marker file being written to disk in the data folder with the name of deploy. It's by monitoring this directory for a file with that name that Umbraco Deploy knows to trigger the extraction. One level up, we have an HTTPS endpoint that can be called by an authenticated request. This will write the file, which will trigger the extraction. And going up one level more, we have a PowerShell script that when executed will call the endpoint, which will write the file, and which will trigger the extraction. So whilst it might be possible to have the CI/CD step directly write the file or call the endpoint, so long as the tool you're using supports running PowerShell scripts, we'd recommend using that method, as it has some necessary error checking and retry logic built in. Let's look at a build pipeline then and see how this is done. I'm using Azure DevOps here, but the steps should be translatable to the tool of your choice. Clicking into the pipeline, we can read the definition. It's a two-stage build process divided into a build and a deploy stage, and it's configured in a YAML format. Although initially this isn't as easy to read as the drag and drop list of tasks available, it does have the benefit of being managed in source control. The first thing to note is the trigger. This pipeline will be initiated following any merge or commit into the main branch. We then have a number of variables defined that are used in the build configuration below. And by using variables, we have the ability to modify the script easily for use on other web applications. I'll not go through each one now, but I'll refer back as we look through the build steps. Each stage, the first of which being the build stage, consists of a number of tasks. The majority of these are standard things that you'll be doing in any web application release, not just those for Umbraco websites or Umbraco websites using Umbraco Deploy. So to start with, there's an install of the NuGet tooling, followed by a restore of the NuGet dependencies, and following that, the project build. The build is using the publish profile that we looked at earlier to publish the output to a temporary disk location. We then get to the first deploy specific step. The Umbraco Deploy license file needs to live in the bin folder, which here we have checked into source control, but we haven't defined it as part of the CS project file. So we copy it over to the bin folder of the published web application using the values defined in the variables. We then carry out a similar step for the data files. They are checked into source control, but as we've discussed, they need to be part of the build output, so they are deployed to the destination site. The last steps in the build stage prepare the build artifacts, of which there are two. One being the zipped up published website, along with the schema data and license file. The other being the PowerShell script provided with Umbraco Deploy that we'll use to trigger the extraction of the schema files and update of the target environment in the deploy stage. The deploy stage consists of two steps. Firstly, a web deployment, taking the package build artifact and deploying it, in this case to an Azure web app. And the second step is Umbraco Deploy specific, to call a function defined in the PowerShell script and trigger the extraction. We need to provide the API key to authenticate this operation, which we could retrieve from a variable, but in order to add an extra layer of security, we get this from an Azure secret. Finally, let's see this in action. I'm in the development environment here and we'll add a new property to a document type. Checking my Git repository, we can see this has caused an update to one of the Schema files, which we can add, commit, and push to the main branch of the source code repository. As we saw, a push to this branch will trigger the build pipeline, which after a few seconds starts running. And then, with the benefit of a short fast forward in time, we can see it is completed. Checking in the target environment, we can see that the updated property is available and can be used in the creation of content. Let's move on now to part 2 of this talk and discuss how Umbraco Deploy can be integrated with in order to use it to deploy your own data, stored outside of Umbraco, perhaps in custom tables or in a separate database, but managed within the Backoffice. I'll start with a little demo of what I'm talking about. Here you can see a Backoffice displaying some content, but actually it's not Umbraco content, it's information read from and written to some custom tables I've added to the Umbraco database. You might first ask the question of why you want to do this, and of course if I really was building a Giro d'Italia website, I'd likely have pages for stages, teams and riders, and hence would be best storing these as Umbraco content. There are, however, cases where you might have data that doesn't fit so well as Umbraco content. Perhaps it's not rendered as pages, or you don't need versioning or preview. You can imagine an e-commerce package with stores and products, or a marketing package with A/B tests and personas that would like editors to manage the data in a familiar Umbraco context, but actually prefer to store them in some custom way. I've currently got the site configured to consider the custom data as schema, in other words serialized to disk on change and deployed via the file system updates. So if I make a change to one of these records, we can see that its content has been serialized to disk. And opening one of these files shows the JSON representation of the data. If I then copy the file to the target environment, I can then log in and navigate to the deploy dashboard in the settings section, trigger the extraction, and note that the change has been applied and is visible via the Backoffice. Having now made a configuration change, the custom data is instead being managed as content, so is deployed via the Backoffice using the familiar deploy menu. For example, I can queue the custom data for transfer, trigger a deployment, and observe the updates in the target environment. Before taking a look at how this is set up in code, let's first review some of the deploy concepts. Firstly, we have entities, and these aren't tied to deploy in any way. They're the responsibility of the package or the solution developer and can be written and importantly persisted in any way into any data store that you prefer to use. The first deploy concept to consider is an artifact. This is a container object that represents the entity. This does have a deploy dependency extending a base class and importantly is serializable. It's the representation of this artifact that is written to the files on disk for schema transfers or posted in HTTP requests for content synchronization via the Backoffice. Service connectors are classes responsible for the mapping between entities and artifacts, and they also handle dependencies. So within Umbraco, if we have a document type, it will depend on various data types for each of its properties. And in the custom data example I just showed, a rider had a dependency on a team. It's the service connector that associates this information for deployments and ensures that the necessary dependencies are either already in place on the target environment or included in the deployment. And finally, we have value connectors. These also manage relationships, but at the level of a property. So within Umbraco, we could have a content item with a property of a form picker. And the value connector for the form picker property editor would relate the selected form to the content for deployment. As I showed in the demonstration, custom data can be registered to be deployed as schema or as content. And for the former case, it's necessary to register the entity with Umbraco Deploy's disk entity service, such that it's recognized as a known type that Deploy can handle. In addition, events such as created, saved and deleted need to be available and handled such that the serialization of the entity via its artifact to disk happens when any changes are made. Deployment via the Backoffice as content is a feature being currently worked on, and it will come in a release in the hopefully not too distant future. We've introduced an analogous transfer entity service that the entity needs to be registered with. In this case, it's a bit more complicated, as we also need to associate the details of the Backoffice tree by which the entity is being managed, such that when an editor queues an entity for transfer by its ID, Deploy knows which type it is in order to utilize the appropriate service connector and artifact. So now let's review this in code. First of all, I've got an Umbraco composer responsible for adding a couple of additional classes to the pipeline. One is the race data service, which as you can see defines methods for the create, read, update and delete operations of the various entities, the stage, team and rider. In addition, it also declares events that will be raised when certain data operations take place. Then there's an Umbraco component, which is responsible for registering the entities with the appropriate deploy service. We'll come back to this once we've reviewed a few other files. As discussed earlier, for each entity we have an artifact, and we're looking here at the one defined for the stage entity. It has a property for each of the entity's properties, and it extends a base class called Deploy Artifact Base. As you can also see, its constructor takes a UDI, effectively a GUID-based ID, and an optional list of dependencies. Each entity also has a service connector, which is a little bit more involved, so in the time available I'll just note some key points. Firstly, again, there's a base class to inherit from, which requires type parameters for the artifact and the entity that the service connector will be working with. Via the constructor we provide an instance of the race data service, as the connector will be responsible for retrieving and saving stage entities as part of the deployment operations. It has methods for retrieving an entity from its ID and mapping this to an artifact representation. It also has methods for carrying out the reverse operation, taking an artifact that has been deployed to a target environment and either creating or updating an entity on that environment as is appropriate. This process of update can, if necessary, be more complicated, being handled in more than one pass of a deployment update in case information from other entities included in the batch are needed. In this case though, it's a simpler one-pass operation, mapping the entity from the artifact and creating or updating it depending on whether it already exists. As mentioned, service connectors also handle the dependencies between entities, and we have an example of that in the rider service connector. As riders are nested within teams in the tree, a rider can't be deployed without its parent team, so we can configure things that way, such that if we try to deploy a rider, its team will be registered as a dependency and, if necessary, transferred as well. Time now to switch to the Umbraco component responsible for the service registration. As you'll see here, I've got a hard-coded flag used to switch between schema and content deployment modes, which of course in a production application could be retrieved from configuration. Let's take the simpler disk entity service registration first, used when deploying the entity as schema via file deployments. Here we have to call the registered disk entity type method in the injected disk entity service, passing the alias of the entity type. For both methods we also have to wire up an event, such that if and when an entity is created or updated, the write artifacts method on the disk entity service is called, which will serialize the data to disk. We also update the signature for the entity in the database cache, which is used as an optimization for deploy to effectively have a cached representation of each entity held in a database record, allowing it to check if an entity requested for deployment actually has changes that need to be applied. The other approach, treating the entities as content transferred via back-office operations, is similar but a bit more involved. Instead of the disk entity service, we use a transfer entity service to register the entity with. But this time, as well as the alias for the entity, we need to provide a bit more information, mainly about the tree via which the entity is managed in the back office. Firstly, there's a pluralized name, which is used in the user interface to show the numbers of each type of entity that have been selected for transfer. Then we have some permissions, so it's possible to control which deploy-related operations are available to the editor for a given entity. And next, the alias of the custom Umbraco tree via which the entity is being managed is provided. The next three parameters are functions used in hooks for various back-office functionality. For example, when customizing the menu for a tree, Umbraco exposes the node ID and the tree alias that's being rendered, and from this we need to figure out which registered entity is being managed. As such, these functions are mostly needed for flexibility in more complicated scenarios where we have more than one entity managed in a single tree. In my example, stages were in their own tree, so we can have functions that simply return true and pass the string representation of a node's ID into a GUID. Teams and riders, though, are in the same tree, so the tree alias and a GUID-based node ID isn't enough to identify which of the two entities it is. We can register slightly more complex functions here, though, to account for this. I've chosen to render teams and riders with a prefix on their node IDs, so we either have the string team or rider followed by the GUID, and hence by parsing the prefix we can identify which entity needs to be deployed. As I say, this last part around the transfer entity service is a work in progress, and this is slightly a sneak peek into something that's coming soon, and some of the details you've seen today could change. But hopefully it gives an insight into some of the work we're planning with Deploy, looking to remove some of the hard-coded knowledge that Deploy currently has about Umbraco entities, and aiming to make it possible to fully integrate with custom solution or package data. And that brings us to a close. I hope that was a useful intro into both working with and extending Umbraco Deploy, and thanks for joining me today. Enjoy the rest of Codegarden.